So, how's your night going? Are you ready to go off on a random YouTube tangent? Because this lamp was sent to me by Ben Golden, and he sent me it for a very good reason. You see, Ben is a member of a carnival club. He performs on a float. I think he's technically involved in the floats as well. And every year, carnival clubs in the UK make these massive floats. And as you can see, it's absolutely covered in lamps. And it's not just lamps, there's a lot of movement too. Take, for instance, this one's by the Globe Carnival Club. And this one is the Gremlins, I believe. And what's really spectacularly impressive about this one is that this, that, they all rotate. They've got slip rings, so there's continuous movement. And the whole cart, the whole stage that they're on also gyrates about. It's all driven by electric motors. It's spectacular. But getting back to Ben's float here, as you can see, it's got a lot of lamps in it, and they are traditionally tungsten lamps, and they're put into festoon. And these floats, there's usually multiple carts with either a generator being towed behind a huge industrial three-phase generator, or it's sometimes built into the last float with some movement just and LED panels or light panels, just say, around it just to try and hide the fact that there's a big generator there. However, thanks to the wonders of the European regulations saying, you know, they're trying to get rid of tungsten lamps, suddenly it's got a bit trickier because technically speaking now they're going to have to move to LED lamps like this. And you think, oh, that's okay because, you know, it's straightforward enough, except some of the carnival clubs in the UK have tried lamps and have fallen foul of power factor. You see, if we use these at home, then we don't have to worry about power factor. Power factor is when you've got the main sine wave alternating between positive and negative. And normally, if you had a tungsten lamp, as was traditionally used in these floats, then the current and the voltage would more or less be completely in sync. However, when you use a lamp like this, which has an electronic power supply in it, the current and the voltage suddenly end up out of sync, and it results in a bit of a more complicated situation. This lamp is rated 3.4 watts, and if you plug this in your home, then it'll light up and draw roughly 3.4 watts. And you don't have to worry about the fact that the current and voltage aren't in phase because you won't be charged the fact that the power appears to be different. However, the electricity companies do have to allow for that in their cabling because it does look to their cabling like, and their transformers like, higher current. So let's plug this in and test it and see what it looks like. So I'll bring in the slightly flickery but quite comprehensive hoppy tester here. And we'll plug it in and we'll plug the lamp into it and we'll see what it comes up as. So I'll plug this in and I'll bring this up so you can actually see it. So let's change the exposure to try and lock on that and focus on it. So it's showing roughly 27 milliamps, let's say 30 milliamps. It's showing a power of approximately 3.6 watts. And the power factor, which is the important bit here, is dreadful. It's 0.5. And that suggests that possibly this is a capacitive dropper in here. It's the most likely bit of circuitry for that. So let's focus back down on that and take this lamp to bits. Now, perhaps before taking the lamp to bits, we should do a little bit of maths to see what sort of effect that's going to have. So let's sit this down here. Let's make sure the exposure is sort of acceptable for that. It's better. And this lamp measured, it's rated about 3.4 watts. Let's just say 3.5. It's a nice round figure. So imagine you've got a 10 amp circuit breaker on let's go for the European standard, 230 volts, 10 amps. With a 230 volt supply, that's going to give you roughly 2.3 kilowatts, which sounds like a lot of power. You know, you could theoretically run a lot of lamps. So the 2.3 kilowatts, let's bring a calculator. Let's go back to the little dinky one. 2,300 watts divided by the 3.5 watts of the lamp, oh, that was wrong, 2,300 watts, oh god, that's even worse. 2,300 watts divided by the 3.5 watts of the lamp equals, theoretically you could run about, say round it up, 660 lamps on a 10 amp breaker. But in reality, because the current we were measuring was about 30 milliamps, it would be closer to 10 amps divided by the 0.03 30 milliamps. It would be closer to 300. I mean, this is... Power factor is a really complicated subject, but this is a rough indication. But you wouldn't get... If you tried running 660 lamps, you'd have the potential risk that the breaker would trip. It would actually detect an overload under that. So you're actually only going to be able to run 330 or so lamps. But I would say, I wouldn't even run that. I would say 200 maximum on a string, just to allow a good margin. Particularly allowing for the inrush current of capacitors in these when you turn them on. So Ben was actually saying... they were thinking of using these LED lamps. They could get a good price on these if they bought 1,000. And he asked if we could send one so we could take it to bits and look inside and see what we thought. So let's open this up. I'm going to try and open this with a spudger. I think this is glued shut. I can see what looks like siliconish glue down at the side. So let's try and slit round here without slitting my fingers. This may not come out easily, as I always say. If it doesn't come out easily, we'll... Oh, this is quite promising. Have I managed to mangle my spudger in the process? Oh! Yeah, it's not opening that easy, is it? I'm going to end up bursting this. I'm going to end up changing the shape of this spudger. Now let's use the brute force screwdriver instead. I think this lamp cover is plastic. It feels like plastic when you try it against the teeth. I think it's probably glued in with that silicone stuff. Now, I want to say my description of working out a load of the LED lamps was perhaps oversimplified. It's not straightforward. So what do we have here? We have 1, 2, 3, 4, 5 LEDs. Now those might be multiple chip LEDs. I can see some screws here. I wonder if this actually has a little switching power supply or if it's a capacitive dropper inside. It's a little switching power supply. That makes things just a little bit even more complicated because that means this is probably a buck regulator. And that means that depending on the type of circuitry, there may be a little capacitor on the input. Although having said that, the buck regulator ones, as opposed to just the standard switchable ones, they don't tend to have a capacitor on the input. This, I'm going to have to desolder these to get this out. One moment please, I'll be back in a jiffy. So it is a little buck regulator. It's based around the classic Brightpower BP99188B chip. Now, before MD mentions that this says confidential across it, it's not just on their website, it's on just loads of other websites as well. It's just a standard data sheet. I don't know why they put this on it, unless it's initially when they release it to the LED manufacturers, the lamp manufacturers, before it's released to the general public. It might be that they just left this on. I'm not sure why they do that. However, it's very similar to the schematic here. Hold on, I'll just zoom in this a little bit, in fact. Let's go up to this. The only differences are that it's got a capacitor across the incoming supply. It's got a little inductor here. And the rest of it is more or less as shown with the LEDs. I believe these LEDs are multi-chip LEDs. So it's quite a nice modular construction, this. The fact it just plugs together like this. You know, the two pins solder into the back of the socket, and then this LED circuit board just clips in the front. However, and I'm just going to zoom out again here, This does all introduce another layer of complexity, because now every single one of these lamps has a little switch mode power supply in it. And now we don't just have to worry about the power factor, but now we've got to worry about harmonics and increased current in the neutral as well as the power factor. It gets really complicated. And I was thinking one of the simplest lamps I've come across so far, the simplest LED lamps, is the filament type, which looks quite good as well and is quite robust. And one of the ones we've looked at in the past of these actually had a circuit which consisted of the same chip that was used, the same style of chip effectively, that was used in these driverless LEDs, that was basically a little current sensing circuit, and it just acted as a variable resistor because the combined voltage of these LEDs comes pretty close to the mains voltage anyway. And these had an appearance, to all intents and purposes, as not quite perfect, but close to near unity power factor, almost like a tungsten lamp. So in a sense, I'd be tempted to try something like these. I wonder how they would be. I wonder how susceptible they would be to the vibration, because the floats do have a lot of continuous vibration. It's tricky. It's a very tricky subject. Now, I know that another, I think it's the Marketeers Carnival Club, have experimented with high-power LEDs mounted in heat sinks and with what may actually be switch mode power supplies putting out a regulated voltage. And I don't know if they've got resistors or they've just set the voltage to match more or less the sort of the combined forward voltage of the LEDs in these arrays of round about, say, the 30 volt mark. But I'm going to provide a link. I'm going to provide 3 links in the description of this video. One of them is going to be to Ben Golden's YouTube channel, which will show you a wee snippet of behind the scenes and the preparation of the floats as they go around all these different festivals, these different sort of carnivals. The other one is going to show what is, I have to say, for movement, one of my favourite floats. It's the one by the Gremlins, because the movement in this is fantastic. And the other one will be a link to, I think it's the Marketeers, blimey, what's the name of it again? It's a space machine, I can't remember the full name of the thing. But it's the one that's got all the LEDs in it, and it looks very spectacular. But it looks complex. I'm not sure what they've used to drive the circuit, the LEDs. If it is as simple as a resistor or just direct driving, I'd guess they'd probably have to have a resistor just to balance the current between them a little bit. But I'll provide the links, and that will send you off in the sort of a tangent through YouTube of these carnival floats. They're just spectacular. You know, they actually make Disney look a bit crap. And you have to keep in mind that the carnival clubs are strictly manned by volunteers. It's men and women who just do it as a hobby thing in their free time. They do all the art, they do the construction, the welding, the electrics, and then ultimately a lot of the performers you see on the floats afterwards are also involved in the construction. It's just spectacular altogether. But going back to the question of what would I use, tricky. I would say if you're going to use these lamps, keep the circuits modestly small, because there is another aspect here. I'm going to bring the notepad in again. I'm going to bring the notepad in because if you get a traditional tungsten lamp, if you've got a large array of tungsten lamps in parallel in festoon, and one of them blows, quite often it will just, you know, the lamp will, with its filament inside, it will just go tink and it will just open and that lamp will go out. Sometimes with tungsten lamps, what actually happens is the filament breaks, but it sprays off little droplets of metal as it breaks, and you end up with what's called, well, what is effectively an uncontrolled arc lamp. The metal vapour conducts across, and the heat of it, the current flowing between the broken ends of the filament liberates more metal, and you end up with an out of control sort of arc situation. And if you've ever had an old tungsten lamp, you turn it on and there's a loud pop and a flash, a blue flash, and sometimes it trips a breaker, then that's the sort of this situation where you've got the lamp effectively turning into a little arc lamp inside. It's kind of rare, usually happens with the smaller lamps. However, once you start going to LED lamps, you end up with a really tricky situation that they may actually go dead short when they fail. If the circuitry fails, they can actually not just blow clear. You can end up with a whole festoon with the lamps along it. And one of those lamps fails and it'll take out the whole string. And when you reset the circuit breaker, if the fault doesn't blow clear, if it doesn't actually blow something in the lamp like this fusible resistor here, you may end up having to literally go along that whole festoon, taking out the lamps and then plug them in one at a time until it goes bang again to find out which lamp was faulty. It's extremely annoying. So I would say my approach to this would be to divide the lighting down smaller circuits, and this is a bit annoying again for the guys and gals making these floats, because they have three-phase distribution boards and a lot of the outlets from those are feeding the motors, so they want to probably keep the lighting on the minimum number of circuits possible. And that means that, they don't really want to start putting too many sub-circuits, although it is always a better way to go. So it's a really complex subject, isn't it? When you've got the lights on a rotating object with slip rings, where you've got the carbon brushes onto the brass the brass rings that are rotating on the feature that is moving, you also introduce possibility of electrical noise. And the electrical noise can play havoc with some of the switch mode circuitry in these. It can actually effectively age it prematurely or cause erroneous results with the actual switching components. It can make the chips in them fail, and that can result in them going short circuit. It's just such a complicated subject. It really opens a can of worms. What was wrong with the old tungsten lamps? Certainly in a specialist application like that. So the answer is, divide everything down into smaller circuits, and best of all, get some sample batches of lamps, get some festoons set up and just run them for a long period of time and see how they last, because that's the only way you're going to tell if they're going to prove reliable in the long term. Particularly once, the last place you want to find that they're unreliable is when you get the float out and there's vibration, there's electrical noise, and it's in the parade and suddenly stuff starts popping. It's actually just a really complex subject. But anyway, as I say, if you look down the descriptions down below, I shall provide you 3 links, one to Ben's webpage, one to a video of the Space Machine one with the LEDs, and one to the Day of the Dead one with just all the movement that just looks fantastic. It's the sort of float that Disney would kill for. But so that's going to probably take up part of your evening. I guess once you see these links that YouTube throws up, you're just going to go off at a tangent. And as I say, the synopsis, the idea of using the LED lamps is start small, just divide everything into smaller circuits and test them to see how long they're going to last and if they're going to cause problems. Because suddenly just plunging in and changing every lamp to LED could be expensive if it just turns out they're not suited to the electrical environment involved. There's one other thing I want to add to this video, and that is that I did suggest to Ben that he could use cabochon caps, and he said they'd tried them but they weren't that bright. Now, cabochon caps are the fairground caps that look sort of crystally, they've got the sort of the base and then they've got the domed front. And the lamp that goes into them, it's usually small Edison screw and usually 60 volts. The reason for the 60 volt lamps in the fairground industry is twofold. Firstly, the traditional tungsten 60 volt lamps were really robust. They had stronger filaments. If you use in the 110 volt or 220 volt, 240 volt one, should I say, then the filaments are a lot weaker. Also, because the lamps are smaller, it meant that, particularly in an outdoor environment, you had mains voltage. If you just used them individually, you'd have mains voltage across these small lamp holders, and it caused problems with arcing. By putting 4 in series, 60 volt lamps, you reduce the voltage across them. And that also has another effect. The 60 volt lamps are stronger. Plus, because you've got 4 of them effectively in series, then if one of them does fail, whereas these small lamps, they are really prone to that problem of the arc occurring inside when they fail. With two 40 volt lamps, it causes major problems. With the 60 volt lamps, even if that occurred, you've got the 3 other lamps in series with it, they'd limit the current, and that means it would fail in a controlled manner. So you've got the more stronger filaments, you've got the lower voltage across the lamp holders, and you've got the resilience against, a lamp failing catastrophically. It just makes sense. The LED versions of these tended to have the screw thread in the back. Oh, that's not a very good screw thread. The screw thread in the back, and then a little module on the top, or a circuit board, which had LEDs facing forward, plus some of them have the LEDs facing sideways, and some even have LEDs underneath. And from the ones I've seen, these tend to use resistors in series the LEDs, because being 60 volts, if you've got maybe I say 1, 2, 3, 4, let's say about 15 LEDs, that's going to be around about 45 volts, so you don't have to have dropped too much across the resistors, so they can just smatter a few surface mount resistors around these, and it means that it looks like one of these. It looks like a fairly LED and resistive type load. It's very simple electronically, it's very robust, and it makes them very suitable for the flashing, which fairground rides use a lot of the flashing of the lights. So the cabochon, used in bulk, it is quite bright. I mean, look at the fairground rides, they're not bad, but there is this whole status symbol going on of the whole. I mean, these carnival clubs are engaging in competitions, so the brighter the better as far as they're concerned. They want it to look like an absolute blazing glory of light. But my own approach might be to actually say, perhaps increase the number of lamp caps and go for the cabochon, because the cabochon, it's not that expensive, the fairground lighting, and it is designed for that type of environment. Certainly I'd be considering the cabochon approach in bulk, even though it might involve perhaps a little bit of extra work with the wiring, particularly given that you can't, traditional festoon, with the tungsten lamps, it's just basically one flat cable going behind them all, and the spikes poke through it and make connection. But when you've got the fairground style caps with the 4 in series, then you have to then have the sort of live going to the first of those 4 and the neutral going to the last one, then little wire links in between them. It just makes wiring them that little bit more complicated. I should mention that also the first of the fairground caps were just bare circuit boards inside, and you usually change lamps while the power's on. And the guys, when they first came out, they were changing these lamps, basically holding the circuit board and screwing it into a live holder. That didn't end well. The modern ones tend to actually be dipped in resin, so it provides that electrical insulation and also the water resilience. And they are very robust. They're strong electrically and mechanically. So, yeah. If the LED lamps did prove to be a problem, cabochon fairground caps might actually be the way to go. If you get them from the proper fairground suppliers and not the fashion suppliers, then they're literally £1 or £2 per cap and LED for it. It doesn't work out that expensive. But yeah, it's an interesting subject, a complex subject, but a very interesting subject. So yeah, I've put those links down below in the description. I'd suggest taking a look at them. You'll find them very interesting.